All right. Hello, everyone that is joining us right now for our
Hello,
Interacting with
everybody.
Sensors, our Interacting with
Hi.
Sensors webinar, part 2. So if you missed part 1, we do have the recording of that on our website. So please check that one out. So this is expanding on our webinar from last month. You'll still get kind of an overview of what we discussed, but then some additional stuff as well. So we will go ahead and get started with some introductions and agenda and all that jazz. So first, if you've never connected with us at all, please do. We've got email on there. We've got our website, all of our social media. So find us, follow us, share all that fun stuff, and check in every so often. We love to know what you guys are doing. All right, so who are we? So my name is Kristina Davis. I am the curriculum manager here at UB Education, former elementary teacher, and many other titles and hair colors before this. My email is on there along with my Twitter and LinkedIn handles. Please find me. I love following you guys. I love seeing what you're doing in the classroom and just connecting in general. And I'm going to turn it over to my co-host, Rusty.
Hello, everybody. So my name's Rusty Nye. I am the EDU product manager, also former teacher and current STEM enthusiast. I like all things techie, robotics, and tinkery. So I'll be kind of leading you guys through a lot of the hands-on portion. So excited to share all the stuff that I get so excited about with you guys. Excellent. So what we're going to do today is we are going to revisit our sensors, just as Kristina mentioned, touch on what we kind of went through last week, or last month, I should say. And then also just turn it over and we're going to start playing with stuff. So I brought a robot with me today. You can see that I am in one of our demo rooms, angled the camera purposefully to make it look a little bit cooler here. Over here is a bunch of other parts as well, but it is very messy because we are tinkers and we are constantly building and constantly trying different stuff out. So yeah, we're excited to show you guys what we can do and what we work with our UKITs. Kristina, I'm going to let you take the UKIT.
No worries. All right, so a little bit about us, if you are unfamiliar with us, we are passionate about preparing students for the future, right? So we want them to get hands-on. We want to give them high-quality products to use. So we have robotics kits, we have STEM curriculum. We are working on new curriculum for 2024. So if you haven't used any of our stuff, please get on our website, check it out. Just really preparing students for where they need to be for career fields that don't exist yet, right, in the future. So that is our goal.
Excellent. So I'll take it over from here. Thank you, Kristina. So great. So this is a slide from last month. These are the main components that we work with in terms of sensors. From here, we are going to define what we mean by sensors and what those sensors kind of enable us to do. But first, I want to actually look at the physical components, and I have them all kind of sitting over right here. So the first one that we'll touch on is the one featured probably the most over our robot catalog, and that is our IR sensor. So you can see here, all of our sensors are proprietary, meaning we manufacture, we make these guys. They work, exclusively with our stuff, and they are pretty awesome. So our IR sensor is utilized in a lot of our robots, and vehicle robots and stationary robots, and this really is intended to detect objects and the changes in distance from objects from our robot. So that's why it's perfect for our vehicle robots. Say a vehicle robot is driving around a room, about to hit a wall. This sensor can detect that it's getting close to that wall and change directions, stop, or back up. It does use infrared light to supply that data to the robot. And so it is actually sending out a signal from one of the lenses here and then waiting to reflect from an object and then return to the other one. Our IR sensor does have a range limit, I should say, of about 20 centimeters, which is only about, this far, which makes it perfect for our classroom robotics. In addition, we also have a pretty nifty pressure sensor. So you'll see it says touch sensor, pressure sensor, or button. These are all synonymous terms for this type of sensor. So this gives input data. So it gives information to our system by applying pressure to the surface of the component here. You'll see it is enabled with a nice clicking sound. Where's our like, you guys hear that clicking sound? It's pretty fun. So it does activate in 3 different stages: a single touch, a long hold, and also a double touch as well. So I'll demo this for you guys as well as the IR sensor. These are both included in your UKIT Intermediate as well as your UKIT Advanced or UKIT Explorer. In addition, our UKIT Explorer, formerly known UKIT Advanced, also features an ultrasonic sensor, which is this really nice component here, which does add a little bit of characterization. As you can tell, kind of looks like eyes. So this interacts similarly to a IR sensor in that it's, excuse me, my primary focus is to detect obstacles that are, you know, close to the robot source, and then send information back. So it does interact, and you know, it does work on a lot of our vehicle robots, in similar cases to our IR sensor. However, it does utilize sound waves in order to get that information back to the system. It works similarly in that it shoots out a sound wave that we cannot hear from here, waits for it to bounce off an object and return. So playing with this one, you get a lot of different types of information and data that you don't with the IR sensor. So the IR sensor acts more as a beam, basically shooting straight out on a, you know, level playing field and then waiting for it to return, versus your sound wave kind of, you know, shoots all the way all around and gives all that information back. So it does have a larger range. However, its range is a little bit harder to define as well. So both of these we can play and get real-time data reads. So meaning we can look at the observable information coming into the system. And I can also demo that for you guys. In addition, something we always mention as well, we do all of our kits except for our UKIT beginner do feature these nice output LED components. Each kit does have 2, which really add a lot of personality to your robots. These are RGB LED components. They have 8 individual components on the interior, which you can operate and turn on and off independently, which is super cool. The reason I'm also showing that is going to interact with our robot that I'll demo for you guys. Of course, it doesn't have any input information, so it doesn't provide any sort of data inside the system. It just, you know, offers that visual, you know, outside the system. And lastly, in our most sophisticated looking sensor is our grayscale sensor, which is super cool. It actually reads like an Arduino Nano, meaning when you connect it, you can connect it and program it directly to the Arduino IDE. And this is a line following sensor. This is actually a collection of 5 different sensors, which I'll kind of show here. You'll see it's branded really nicely as well. So these little gray boxes are sensors. So there's 5 individual sensors here. And you'll see each sensor has 2 different metal connectors on either side for each component. So there's actually, I should say, it has 4. So it has, you know, 2 that are reading, or 1 that's reading light and 1 that's reading dark for each of the 5 individual sensors, which is super cool. So this can give a really accurate reading of a light and dark. So it's basically sort of, you can think about it like a binary sensor, where it's going to read just one thing or another and just light from dark. This is great and really intended for line following. So if you guys have worked with other robotics kits that focus on creating a robot that follows, you know, on a line, this is the type of technology that they're using. Except theirs usually don't look as cool as this one. This is just a cool component for sure. Great. So moving on. So that's a lot to wrap your head around. That's what we work with here with our UKITs. So what is a sensor? How are we going to define a sensor? I'm going to supply a couple of definitions here. But this is kind of your first step, especially when you're talking with students, to try to wrap your head around what we're talking about. What are these electrical components? So a sensor, the way that we define and think about it, is an electrical component that interprets, collects, or relays any type of information. So I would ask a student, what type of information is an IR sensor providing? And you might want to say, well, it's providing infrared information, but it's not. It's actually converting that into a object, right? Or not, I shouldn't say that. It's converting that information, that IR information, into an object's distance. So it's actually providing a distance, a readable distance type of information, which is kind of a cool, interesting thing to wrap your head around. Contrary, what is your touch sensor providing? What kind of data? So it is actually providing pressure. It is actually providing data on the amount of pressure pushed onto the surface of the actual component itself. So all of this can be talked about in terms of data. And a sensor is something that's going to collect or relay. And the reason why it's collect or relay is because sometimes our sensors aren't really storing any type of data. They're basically like open windows, letting that data pass through to the system. And that system, your computer, your robot, is interpreting that type of information.
Hey, Rusty.
Yes.
We have a question. Can you give an example of how you would use the touch sensor?
Absolutely, and I will show you momentarily. So there are a few cool different uses. I've also seen it attached to vehicle robots, which you can activate similarly to an IR sensor, or utilize it in a similar fashion. In that, if you position it on the outside of a vehicle, if this touch sensor, hits a wall and gets activated, then it can back up or something similar. Or you can, utilize it as a way for a user, a person to apply pressure to the button to turn off or turn on a component of your robot. So a touch sensor or a pressure sensor, again, can also just be, labeled as a button. So it's a way that we can interact directly with our robot. And I'll show you guys how we can use this momentarily. Excellent. So looking at an example, and I kind of went over this last month, so I won't touch on this too much, and I kind of already, I guess, went over it without meaning to, but an IR sensor that we work with, this is our primary sensor that we utilize to kind of teach how sensor data goes from one place to another, and how we convert that into data that we can use to interact with our environment. But if we can kind of break down what's actually happening here in this little component, this little plastic component is actually doing a ton of really cool work. What it's doing is sending out a light from one of the lenses that we can't see. We'll never be able to see it because we don't actually see light on the infrared scale, or spectrum, I should say. And then it's basically shooting out a ray and waiting for that to reflect off an object, so reflect off of a UKIT or something similar, and then return back to the sender. So I guess receiver. So the other side, the other lens. And then what it's doing is calculating that distance, how long it took to send out and then come back, and then converting that into a readable value expressed in centimeters. So a lot's happening there. And basically all we see is that data, that conversion, that value of centimeters. And we use that to interpret and interact with our robot. So pretty cool, a lot happening, but we just need to know how we are going to interact with that value. The way that we can kind of think about it, because that's a lot to think about, right? So the simplified definition and how we talk about the uses of sensors, how I like to simplify it, especially with students, is that sensors allow outside interaction. So what do I mean by that? Let's simplify the simplified definition. So basically what we're saying is that sensors allow robotics, in this case, to be able to interact with their environment in different ways. So let's kind of explore that a little bit more. So us as humans, most of us all have a variety of sensors. So these are your basic identifiable sensors that we teach to youngsters. Of course, humans actually have a lot of different sensors that I always think should be brought into the elementary classroom, but that's a whole different webinar that we can touch on some other time. But when we talk about sensors to students, we generally touch on these 5 general senses, right? We can smell by utilizing our nose, our sensor of the nose. We can see by utilizing and leveraging our sensors, our eyes, etc. So robots have similar sensors, right? So this is an example of Yanshi, who can still perceive and interact with his environment by leveraging similar different types of data reading sensors. And so you'll see the comparison when we start looking at that. In both examples, these sensors, the ultimate goal are to allow the robot or the human to interact with the environment in a better way. So our human example would be able to see what's going on, to smell what's going on, to hear, taste if he was kind of weird and licking a wall or something, I don't know, or touch what's going on. While Yanshi can do something similar, he can also, evaluate, see the information by utilizing the camera. He could detect obstacles in front of him by utilizing infrared sensor. He can detect the temperature as well, etc. So note the main takeaway we want from students when we're talking about sensors is that these sensors, these little components, what they're trying to do is trying to provide a better interaction with our surroundings, with our environment. Great. So now, as promised, we are going to look at some examples and start playing with some robotics. So to help lead this kind of demonstration, I am going to steer you guys towards our browser-based software environment, uCode. So if you're unfamiliar, go to this URL. If you want to open up another window, feel free to do so. You guys can follow along. I'll kind of give you guys a bit of a tour before I connect the robot that I want to show you guys. But this is our browser-based environment that allows us to interact with our sensors, interact with our robots, etc. This can be, our URL can also be found on our website. So, if you're missing this, you don't want to log on, don't feel bad. You'll definitely be able to find it.
Rusty, can I chime in real quick?
Yeah.
All right. So for those that have been with us for a while, we're fairly new to Teams, so I'm still not quite sure who has access to chat and who doesn't. But in the Q&A section, I did just put the link to our website, the link to uCode, and another link to uCode activities and resources that we have from our website. So please feel free to check those out at your convenience. Like Rusty said, you can follow along. You can just watch. Remember, this will be recorded. You'll get a link to the recording. So if you want to just watch and take it all in today and then follow along a different day, you certainly can do that.
Awesome. Great. So in terms of uCode, before I jump into the actual environment, excuse me, I'm going to show you guys a little bit of what we'll be working with. So uCode is a drag and drop programming environment similar to Scratch that works in a default environment called our stage mode. This is where we'll be working today, and this is where you can program animations while also interacting with our external components like our robots and our sensors. In addition, we won't touch on this today, but I always like to mention it. And excuse, I think the image is a little blurry, but my apologies there. We also feature a fully functional dual programming environment that automatically converts all blocks into C++, which then can be exported into the Arduino IDE. This is super cool for those educators that want to kind of slowly build onto text-based coding with students that may be comfortable already utilizing block-based coding. And lastly, we also feature a fully embedded AI interactions that include image recognition, drawing recognition, pose recognition, and machine learning model building and more. I'll probably demo a little bit of this momentarily. So great. So enough of that. Let's go ahead and demo and play with our robots. So if you guys are still with me, this is the robot we'll be working with. This is your infrared robot, infrared fan, I should say. And we'll touch on the different components, but I will show you guys what uCode looks like. When you first go to uCode, you'll see it is just this blank screen that is ready to start rocking. To access all of our models and builds, you'll see we have a UKIT Advanced, which is now called UKIT Explore folder here, which features all of our step-by-step instructions. So when I built this robot, I went right here, and I'll kind of walk you through what we'll be building with and what we'll be working with before I turn it on and connect. So hopefully the internet is helping us here today in Teams. We don't have any delay.
That's all right. While it's loading, we should probably note, because it's changed since our last webinar, right? I don't remember if we talked about it or not. So like Rusty mentioned, UKIT Advanced is now UKIT Explore. Same kit, different name, different bin color. So if you go to our website and you've been there before and you've seen the gray kit, it's now a teal color, which is going to be the precursor for many things to come next year. So do know it's not alone, but that one has changed over sooner than the others.
So I'm going to go ahead and skip over that, showing you the 3D model building, and that is due to our Wi-Fi. Yes, we are an advanced robotics and AI company, but we still have Wi-Fi from the local cable company. So sometimes it doesn't work all that great. But what we're going to kind of skip to is I'm going to skip directly to working with some of our sample codes. So if you'll see here, most of our robots feature sample codes that we can work with. I'm going to actually, let me open it up. What you're seeing here is actually a virtual robot, which is great as well, but we're not actually going to work with that because we have the physical one right here. So if I go to our stage mode, I click on our resource center, and I just know this, I know it's on page 2. And you'll see here, we instantly have a really nice code that interacts with our sensor, as well as our different components here on this robot. And one of the reasons I actually always use this robot to demo, because I think this is a great first robot for students, especially, or anyone kind of getting new to the UKIT system. And the reason for that is it's a pretty easy build, though it features one of a lot of different components. So you're not using multiple servos, but you're using one DC motor, you're using one servo, one LED, and then one IR sensor as well. So kind of, you know, all of these, and it's also a stationary robot. If it's your first time building robots, recommend going to one that's not going to instantly drive off of your desk. That's something I have learned from working with teachers. Yeah, that can be frustrating.
Hey, if you're at shows, come to our booth because we usually have something flying off the desk, off the table.
So just before we get this code going, let's just kind of figure out and let's anticipate what's going to happen here. So you'll see, just like other block coding languages, we're going to read it from top to bottom. So when the space key is pressed, that's going to kind of begin the sequence here. First, we have this forever loop. So everything in here is just going to continually run until I tell it to stop. And then we have an if then else statement. And surrounding this if then else statement, the if condition says if the IR sensor here detects an object that's less than 12, and I know that's centimeters away, then it's going to change the LED to red. It's going to stop the servo motor, and it's going to stop the other motor as well, the DC motor. However, if it does not detect an object that's less than 12 centimeters, it's going to start by turning off the LED, so refreshing the LED. Then it's going to activate the servo motor to rotate randomly from negative 70 degrees to positive 70 degrees, which I love that they threw that variable in this example, taking 700 milliseconds. It's also, or then I should say, it's going to activate that LED to color in this pattern here. I actually designed that pattern because I thought it looked kind of cool. Reminded me of Blippi for the parents out there. I'm going to be Blippi for Halloween, everybody. That's why it's on my mind. And it's going to take 300 milliseconds. It's also going to activate that DC motor to rotate clockwise at a slower speed of 100 rotations per minute. And it's then also going to change that custom LED. So let's see if this performs like you guys think it's going to perform. So the first thing we're going to need to do, of course, is connect our robot. Let's see. Let's go ahead and connect it. You'll see I'm going to connect and ignore my skipping of that update. I'm going to connect with Bluetooth here. And then I'm going to reset the Bluetooth connection. And now we're connected. You'll see the little icon turns blue here. We have something connected. And here's a trick. I did mention that we can get real-time data reads. So if I go to this little gear icon here, select a value, it will show me, you'll see I can also get a real-time read on my battery, but I also am reading the information that's provided from my infrared sensor. So you'll see it's detecting an obstacle, which is probably the monitor here, 20 centimeters, which is its limit as well. So if I kind of, I don't know if you guys can see that. If I raise my hand in front of this infrared sensor, we should see that number lower.
Rusty, can you move your mouse just a little bit? I mean, I know you're pointing it out, but just a little bit down so we can, there. It was just kind of blocking the numbers a little bit. Yeah, that's really cool. I can see it.
You'll see. And if I just go really close, cover it, there you go. So you will see our code is anything less than 12. So it's about there is what it's going to activate this time. So let's test that. So let's activate our code by hitting the space bar. Here we go. So it's reading that else statement now. Right? So let's go ahead and activate that if statement. So it was right about here, right? There you go. And if I move it, it's going to activate again.
Yeah. So
you know what we are noticing here? So there's an error in our code. You guys see? Can you point out something that's not working? I know why. So our servo is not working, and that's because we have the wrong label within the code here. Because I actually use servo ID 03, which if you'll see, uCode is telling me that. So uCode is, because the servo is grayed out, that means it's not there. It's like basically, hey, dude, you're connecting a servo that's not even a part of it.
Like a ghost servo.
Exactly. So now let's reactivate that code. Now we got our servo moving randomly, which I think that's such a cool part of this code. Let's get it to stop.
The fan movement looks so cool on video. Like it's.
Does it really?
Yeah, it's very different looking.
Oh yeah. That does look. So it's something that I want to circle back to is that simplified and that kind of working definition of sensors. Because I think this is such a great example. So a sensor is something that allows interaction with your environment, with your outside surroundings, right? So you'll see now I'm able to basically interact with the servo motor, with the LED, with this whole component, this whole robot here in real time. And the way that I'm able to do that is by the use of interactions with this component here. So it allows better interaction with your system. So to increase your interaction, to make it even, better, we can tweak the information coming from the sensor, or we can also add new sensors here. So that's something that I'll do here, just kind of demo and also show how quickly you can kind of just plug in something and get it working. We do use with the UKIT Explore, UKIT Advanced, this Arduino compatible board, which is just a super cool board because it's just really easy. It reads really fast. It's really powerful. Has a bunch of different components, a bunch of different ports as well, so you can plug in so many different components. But I can just simply plug in this touch sensor, and we can easily just write a code for it to do something. So maybe I'll throw this over to you guys. Can you guys think of something you want this button to do or activate? Give me some sort of idea while I kind of build a little bit of a code.
Well, just in case no one else chimes in, I think you should use it to change the color of the LED.
Love it. Okay. Let's do it. So let's go ahead. We'll change the activation block differently. So when I hit that arrow up, we're going to start building our code underneath that. So we're going to kind of copy this format, and that when that arrow the arrow key is pressed, then we're going to put this forever loop and build everything inside of this loop. And then let's go ahead and also put in the conditional statement. We're going to keep it simple and just have an if-then statement. And then we want to put in our touch sensor block here. So we scroll down to our Explore drawer. You'll see under sensors, we have access to all of our sensors here. So we generally don't have to worry about the ID because all of the touch sensors, the default ID numbering is 1. So this should activate. We may have to reconnect to make sure we have the same connection here, or we can also check it this way. So you'll see we do not have a touch sensor connected, but if we refresh, we're going to have to reconnect it here.
I'm positive a few of you on this webinar have a better idea than I did for how we can incorporate the touch sensor. So, oh yes, we have one. It says, use a touch sensor for security, for example, pressure stops the blades.
Oh, nice.
Yes, that is another great idea.
Let's see. Great. And there we go. Now your touch sensor is now connected. Look at all these cool components we have running. Everything is reading, connecting. So let's go ahead and do both. Let's go ahead. We will, Kristina, what color do you want?
Well,
so this is what's so cool. We can do this graphically as well. So we can change it. We're not, necessarily programming or telling it with hex numbers, but we're actually touching and changing the colors, which is cool. Look, I'm default going to that bluey color.
Well, that's why I was just gonna say purple's my favorite color, but blue is my hair color right now. So let's go with blue.
All right. Let's do it. And then let's have it activate for a little bit longer. Let's say we'll do like 2.5 seconds, which would be 2,500. And then let's go ahead and turn off the DC motor. But if we are turning it off, we do have to turn it on, right? So what I'll do is I'll duplicate this and I'll keep that at 0. And I'll put this one at 100. And then something we want to do here is we'll run through this sequence and then go back to this. Well, let's test this. I know we're going to have to change, but it's a good thing to see if it works. So what we're going to do, this is going to be hard for me to do all at once and holding it up for you guys. Maybe I'll just position the camera. Probably a better
Sorry,
option.
I'd Vanna for you if I could. Not there to Vanna. It does.
You know what? I have way too much stuff around here. That's not the best view, huh?
It's not.
It is better if I just hold it up here. I'll just wing it. Okay. hit that up arrow. Look, our sequence is going. You'll see, and nothing happened, huh? Let's go ahead and access this. I think we need to reconnect.
Do we need to reconnect, or does it matter that our ID is different? Aren't we on servo 3 and not servo 1? Does it matter?
Well, this is using our DC motor.
Oh, okay. So not at all with the regular servo. Good to know.
So here we go. I just had to refresh it. So now you'll see now it's reading that first block. Because it's in that forever loop, it's just going to continually rotate. I'm going to hit this button. Let's see if we got it to stop. And you'll see it's activating it. That actually, see, that's actually did exactly what I thought. It's going to stop just for a second because we didn't set it for how long it's going to stop for.
Ah. I'll make all the sound effects for everyone that can talk. Ah.
So that that's actually like I love that. I kind of love that part of programming there because we're telling it to stop, right? But we got to tell it for how long to stop for. Otherwise, it's just going to stop for a second and then keep going. We're just going to say, hey, I stopped. I did what you said. I'm going to go back to this forever loop here. So this is where we want to set an amount of time that we would want it to stop, or we can also do a loop within this if we wanted to say, let's stop forever. Let's just completely stop. And this is where that else statement would also come in handy. So we hit it again. So now, if I hit that button, and now it's not going to start again because it's just stopped. Pretty cool stuff, huh? What do you guys think?
I saw a lot of reactions. I don't know if you've noticed that, different from Zoom, right? Because this is my first Teams. There's Stacy again. Little hearts and smileys, and oh, thanks for everybody who's doing this so we can see them. Lots of reactions coming up.
So you know what I'm actually going to do here? So now we haven't stopped this forever loop. It's not going to start again. So let's go ahead and copy this whole sequence here. And then let's actually, this is going to be super fun, guys. I'm excited. Now, and this is what all your programmers do. They just make one tiny sequence and they just keep copying it and copying it until, you know, they build out a whole program. But so now we haven't stopped, right? So now when I hit that arrow button up, our fan turns on and it's like starting to, you know, cool off the room. Everything's working. We hit that fan once, it stops it. So let's give more data to this sensor here. We're going to do a double press. We're going to hit it twice. And then let's go ahead and change the color of the LED. And then let's go ahead and turn it on. You guys wanted to go faster? What do you guys say?
We had a comment that it was really fast already.
Really?
Yeah.
Let's go 300 rotations per minute. Oh no, I might just fly out the room.
I know if nobody's seen this in person, it gets a little wild because we'll have it at shows. So you got to watch your cables. Don't have any cables close by that are wires that'll get stuck in it. And also it gets pretty loud as it runs. So sometimes we shut it off because it gets kind of obnoxious.
It does. Yeah. So let's test this out. So now you'll see, hit that up button. Both sequences are activated. And so now if I hit it once, it's going to stop, right? So then let me double press it and see what happens.
Nice.
Oh, interesting. Do you see what it's doing now? So now it's just kind of moving at a pretty wonky rate. That's interesting. Oh, you know why? Can anyone tell me why it's moving like that? Kristina, you're the only one that can respond. So
I was like, do you want me to Is it combining the two?
exactly. Yes. So it's basically it's reading. So I'll do it again. Oh, I think I need. Oh, see, it ran through the codes. You guys can see they're not highlighted anymore. So basically, yeah, it was going just flip flopping, reading that one block, and then going back to the other one, going back to the other one, and just rotating between the two blocks. So we'd want to also create some space around, or some express some timing around how long we want it to go for. Oh, it looks like my lights turned off in my office here. Is that a hint? Are we running long here?
You are at 5:43. Well, 3:43 for you. But I will say the only way I could really tell, because the video is kind of hard, is I could tell the light was changing colors and that it was going to red and blue. So like that's how I knew it was combining the two.
Oh, interesting.
Yeah.
So look, if I put this here, it's going to hang out on this block basically before cycling back to the LED block. So let's do this. Here, it's going to run through. It's not going to like it. I'm going to have to. This is when it starts getting kind of tired. And you want to refresh your robot, get a fresh connection. And that's
Stacey's
also telling.
examples, by the way. Great example. Yes.
So I think that's actually a great time to kind of pause as well and then move off. And yeah, generally, if you run it and you're running code a lot, basically your robot does get a little tired and basically asks for a refresh or a break. So this is where you would reconnect, just establish a new connection, and then keep going and keep trying and going with it. Awesome. So jumping back to the slides and to kind of wrap it up, a little bit of a plug as well. We always want you guys to check out all of our resources at our training site. So we do have a training portal, ubtecheducation.tavuti.io. Also, that link can be found on our website. We do host training courses there, all of our curriculum as well as activities and resources. We will also upload this webinar recording there as well. So this is a resource that we build for educators. Specifically, it is 100% free. You can view all of our stuff, participate, get more comfortable with the tools as well. And it's something that is ever evolving. So look for more stuff from us coming soon. Great. So now's the time. If you have any questions, any thoughts, you start collecting them now. You can drop them in the Q&A, or I should say the chat window. But while you're doing that, a little plug. We are actually going to move into our last webinar for the year, which I cannot believe it's already moving into that time. But next month, November 15th at 3 p.m., same time, same day of the week, we are going to be doing a webinar on real robotics, real world robotics. I didn't read one of the words there. So we're actually bringing in one of our colleagues to come and touch on how he solves problems with robotics. Really cool perspectives that can apply to you as an educator, as well as for your students as well. So recommend coming to join. There'll be a lot of takeaways there for sure. Excellent. So I see, if you have any questions, feel free. We will hang out for a little bit.
Yeah, and if you don't have any questions, thanks so much for joining us. And we will see you next month with special guest Drew. It's going to be so much fun.
Excellent. Great. Well, thanks, everyone. Have a great rest of your day, and see you guys next month.
See ya.
Bye.